Now we're going to talk about how to create an incenter. So I have a triangle. Please remember mine might not be exactly like yours. And to find the incenter, what we do is we draw the 3 angle bisectors. So I'm going to begin by measuring each angle with my protractor. So I need to line up the vertex. Zoom in a bit. I need to line the vertex up with that hole, and then I want to make sure that these horizontal lines on my protractor are perfectly lined up with the bottom of my triangle, and I'm going to measure around. So this is 10, 20, 30, 40, 50 degrees. So to create an angle bisector, I need to cut that in half. Half of 50 is 25. 25 is right there. So I can, now that I have that mark, I'm going to create an angle bisector that goes from that vertex right through my mark. And I'm going to just mark on here that each one of these angles is 25 degrees. So that's my first angle bisector. I'm going to turn my triangle and just repeat that process. So I'm going to line the hole up with the vertex, make sure that these horizontal lines are lined up with the bottom of my triangle, measure around from 0, and it looks like this angle is 55 degrees. So just to make life a little bit easier, let's pretend like that's 56 degrees. It's pretty close. So 56 degrees, if I cut that in half, I'm going to get 28 degrees. So I'm going to go again from 0 over to 28 degrees, and it's right there is my mark. I'm going to line up the vertex to that mark, create my angle bisector, and just mark again that each one of these, I forgot how many degrees was that? 28 degrees. Okay, 2 angle bisectors. My last one, same deal. Line the vertex up with the hole. Make sure that the bottom of my triangle matches those horizontal lines. Start at 0, measure around, and it looks like we've got 10, 20, 30, 40, 50, 60, 70, about 76 degrees. So half of that will be 38 degrees. So 38 degrees. Unfortunately, I'm sort of off of my triangle, so I'm going to do my best to follow the 38 degree mark here. Line the vertex up with that mark. You can see I'm a little bit off because ideally these would all come together in one point. So I'm going to just first mark these are both 38 degrees. I'm showing that that angle was bisected, and then what I do is cheating. I just make a really big point, pretend like they all come together right there, and that is the incenter. Okay, the interesting property about the incenter is that it's equidistant from the sides, and it's really tempting to say, oh, that means that these 3 line segments are congruent, but they're not, because the distance from a point to a line or a point to a side is always a perpendicular distance. So I'm going to grab a different color and I'm going to draw in the perpendicular lines. So the way I'm going to do that is I'm going to line my card up, that's a 90-degree angle, with the bottom of the triangle and that point, and create that perpendicular line segment. I'm going to do the same on all 3 sides. So I'm going to create a 90-degree angle from the bottom of the triangle to the incenter, 90 degrees, and the same on the 3rd side. A 90-degree angle from that point to the side of the triangle. Okay, 90 degrees. So these 3 perpendicular line segments should be the same length. I'm going to measure them because I'm curious how accurate I was. That's 2.5 centimeters, 2.5 centimeters, 2.5 centimeters. Perfect. And I'm going to go ahead and mark that on my diagram. 2.5 centimeters all the way around. So it's really important to differentiate here between the perpendicular lines connecting each side to the incenter and the angle bisectors, which did go through the incenter to each side, but not necessarily at a 90-degree angle. So there's your incenter.